Welcome to this online revision session for AQA FP3, in which we'll be looking at the January 2011 question 8 on solving second order differential equations. Again, being a question 8, there are a large number of parts to this question, worth considerable number of marks, and make certain that you pace yourself correctly through the exam to leave sufficient time to score all the marks in this question. Okay, in the first part we're asked to show that if x is equal to e to the t and y is some function of x, then x dy by dx is equal to dy by dt. Well, we know that dy by dt can be written using the chain rule as dy by dx times dx by dt. And we also know from the fact that x is equal to e to the t, then we can say that dx by dt is equal to e to the t as well, which in turn we know is equal to x. And so we can substitute x in place of dx by dt in here, and so we end up with the result that x is equal to x times dy by dx is equal to dy by dt. So that's part A dealt with. Part B, then, we've got to use this substitution to convert from dy by dx and d2y by dx squared and x in this second order differential equation into a differential equation in terms of y and t. So, what can we use? Well, we can differentiate what we have just found, again, with respect to x. And so if we differentiate the x dy by dx using the chain rule, we will get the fact that this becomes dy by dx plus x times d2y by dx squared, and that will equal, well, we've got to differentiate this with respect to x, the dy by dt, so we'll have to use the chain rule, differentiate it with respect to t, so it becomes a second order differential, and multiply it by dt by dx, which of course we know that dt by dx is the same as 1 over x from over here. Okay, so this becomes 1 over x d2y by dt squared. And so if we rearrange this, this tells us that x d2y by dx squared is equal to 1 over x d2y by dt squared minus, and we're taking this dy by dx across to the other side over here. Now in what we're substituting, it is x squared d2y by dx squared, so now if I multiply through, I get x squared, that cancels out, and then I get x times dy by dx. But I know that x times dy by dx is actually the same as dy by dt. So now if we take this expression from up here, I can now transform this, because the x squared d2y by dx squared I know is given by this part. The 3x dy by dx can be replaced there with 3 lots of dy by dt. The 4y will still be in it, and then we got twice ln x, but I know if x is equal to e to the t, then t is equal to ln x, so this becomes 2t. So substituting, we are then going to get d2y by dx, by dt squared minus dy by dt, and then it's minus 3 lots of dy by dt plus 4y equals 2t. And then of course we can tidy this up, because these two bits here give us our minus 4 lots. So this piece here we can then just tidy up to give us the result that we require here. So where do we get some marks? Well, in part A there's just 2 marks. Your method using the chain rule will get you a mark, and then working through from there with an appropriate substitution to give you the correct expression here will give you a mark. In part B we've got 5 marks allocated. So firstly you're going to get 1 mark certainly for working from what we were given in part A, and differentiating it again will give you a mark. And then simplifying this expression will give you 1 mark. Then the substitution will give you a mark, method mark. And then finally, for obtaining the simplified version at the end, which I didn't actually write, but that would give you 1 mark. Now, well, I've missed 1 mark out somewhere along the line there. Yeah, it's using the product rule to work this piece out. When you expand that, you'll get a mark in there for that method. Okay, to give you 5 marks. But there's more to this question, another 11 marks yet. Having now obtained in part the differential equation in terms of y and t, we've now got to find the general solution to this. So we know to find a general solution we have to solve the equation when it equals 0, and we use the auxiliary equation, which is found from the coefficients of d2y by dx squared and dy by dx and y. And so we've got 1 minus 4 and 4, so this becomes m squared minus 4m plus 4 equals 0. And of course factorises quite nicely into a repeated root, because we get m minus 2 squared equals 0. And so m is equal to 2. Now if you remember, when a root is repeated, then the complementary function that then suggests will become y equals e to the 2t in this case times, say, some constant a plus bt e to the 2t. Okay, so that's the general form that you need to recognize when you're dealing with a repeated root. Then to get your particular integral, you've got to guess some sort of appropriate function. So you may well guess, since it's 2t, that this will be at plus b, using small letters a and b there. So we then have to substitute into the differential equation to find the values of little a and little b. So we first differentiate with respect to t to get dy by dt, and that gives us a, and then we differentiate it again, which in this particular case will obviously then give you 0, since we just got a constant. So if we now substitute that into our differential equation, we get 0 minus 4 times dy by dt, which is a, plus 4 lots of y, which is 4 lots of at plus 4b, and that has to equal 2t. So by equating coefficients, we can immediately see that a must be equal to a half to make 4a equal to 2. And if that's the case, if I got 4b minus 4a being equal to 0, because there's no other term on the right hand side, that tells me that b must have the same value of a half as well. So this gives me my general solution as being y equals a e to the 2t plus bt e to the 2t plus a half t, because a is a half, plus a half. So there's 6 marks for doing that part of the question. So again, you'll get a method mark for working on the auxiliary equation and an accuracy mark for obtaining m as 2, and then for stating then the correct complementary function, you will get 1 mark. Similarly then for the particular integral, suggesting that it should be at plus b will give you 1 mark. For then obtaining b as a half and a as a half, you'll get 1 mark. And then for giving the correct version of the general solution, that will give you 1 mark from there. Okay, then finally we're into part D. Now in part D we're now going back to solve the original second order differential equation given those conditions. So firstly we've got the general solution. Now remember the substitution we did was x equals e to the t, so we've now got to substitute back that. So e to the 2t, if x is equal to e to the t, that's just x squared. Similarly, e to the 2t is x squared, but t will be equal to ln of x if x is equal to e to the t. So this becomes b ln of x times x squared. Similarly again, we got half t, so that's half ln x plus a half. Now the first condition we've got is that when x is 1, y is 3 over 2. So if we substitute those in, we're going to get 3 over 2 is equal to, well, x is 1, so that makes us a. Log of 1 is 0, so that second term disappears. Again, half a log of 1 is 0, so we just got a plus a half at the end. So that tells us that a is equal to 1. And to find the other condition, we're going to have to differentiate this expression. So the differential of ax squared is 2ax. Differential of the ln is 1 over x, so this becomes plus b over x. Times x squared, because this is a product. And then we've got to differentiate the second part, which gives us plus 2bx ln x. And then the differential of the half ln x becomes 1 over 2x, and the differential of the half is 0. Again, we've got conditions that when x is 1, dy by dx is a half. So that gives us a half equals, well, x is 1, so that gives us 2a. When x is 1, that gives us plus b. When x is 1, ln of x is 0. And when x is 1, that gives us plus a half. So that is telling us that b plus 2a is equal to 0. So if a is 1, that means that b is equal to negative 2. And so finally, we can write out our general solution in our particular solution in whatever form it comes out in. So we know it's going to become ax squared plus bx squared ln x fallen asleep there, haven't I? I'm supposed to be replacing, so a was 1, so that goes, b is minus 2, so this becomes minus 2, that part, and then we got plus our half ln x plus a half. You could tidy it up slightly, I suppose, and take x squared out as a factor of the first two terms and write x squared times 1 minus ln x, and similarly take the half out and write a half of ln x plus 1. But either way, whichever form you write it, you would get the marks for that part. And so, allocating marks, firstly again, for writing the correct general solution of y in terms of x, get a mark for that. Then for the substitution of obtaining this constant, you get 1 mark for that. Similarly then, using the product rule to differentiate this accurately, you'll get a method mark for that. And then obtaining the b equals negative 2 from there, you get an answer mark. And then for finally stating the correct particular solution for the conditions you were given, will give you your final mark. Hopefully you found that solution helpful. For more support work for your further maths and maths revision, please go to the Further Maths Support Programme website.